Hey guys, and welcome to the inverse kinematics tutorial for Blender. This is a very important tutorial for those of you guys who want to get into character rigging and do some more advanced rigging, especially with any kind of character that has a ground touching limb of some sort. Feet, hands, whatever, tentacles, I don't know. But if you have some sort of ground touching limb, or even other things where you might want to have an easier way to animate it, inverse kinematics is actually very, very helpful and feels more intuitive for the animator. So inverse kinematics, just to give you an overview of the difference between inverse kinematics and forward kinematics, which is IK versus FK respectively. So we're going to go into exactly what forward kinematics is first, because it's very straightforward. It is the parent-child relationship as you already know it. That's what forward kinematics is, and I'll go ahead and demonstrate it for you right here on Archibald, the rig that we made a little bit earlier. This is going to move the rest of the arm down. As you can see, this is the parent, the upper arm is the parent here, and it'll move the rest of the arm, and the rest of the children will be affected, but the children will not affect the parent in any way. So no matter what I try to do here, I can try to grab it, I can try to rotate it, it will not affect the parent. This is actually a connected bone. This is the parent of the upper arm, so I can try grabbing this one. It does actually move the upper arm bone, but it does not move the parent, which is the shoulder here. So that is completely unaffected, and yet when you move the shoulder, it'll move the upper arm. So this very intuitive parent-child relationship going down the chain of hierarchy and deforming that way, that is forward kinematics, because it's straightforward, moves forward down the chain. Now, inverse kinematics is basically the opposite of that. So what you do is you should be able to move the child and then have that affect the parent in some way. So before we actually get into how to create an advanced inverse kinematic constraint rig for these hands and feet and stuff like that, I'm going to show you a handy tool that Blender has for posing that you can't use for animation. This is not good enough for animation, which is why we're going to use the constraints as well later on. But this is a very handy tool. Over in the T tab over here, you have the Auto IK option under options for pose options. Check that on. And this is, again, this is just for posing. It's just a very simple tool that Blender provides in case you need it for ease of access and convenience when you're posing something, but it's not good enough for animation. But I'll show you. If you go ahead and select the hand of this now, again, we tried it earlier, using the hand should not affect its parents, right? It shouldn't affect its parent at all. But what we have here is, with turning on Auto IK, the hand now affects where the arm bends. So you can actually drag the hand out, and it feels very natural almost as well. We almost think with IK when we move our own hands. So if we're thinking like, oh, I want to move my hand to this water bottle, you know, when we don't think in our minds, I'm going to bend my upper arm forward and then bend my forearm the other way, extend each one of my fingers, you know, and then blah blah blah, and then have the hand like hopefully reach the right spot. That's not how we think about things, right? We think about things in a more IK manner. We sort of want the hand to go somewhere, or we want the feet to go somewhere, and our knees and our elbows compensate for where they want to go. So that's a very intuitive way of bending it. But here we go. This is the IK example. Now, how do we actually achieve this with rigging? Because right now we haven't actually rigged anything. This is just the Auto IK. Again, this does not actually work for animation, but let's go ahead and go into the constraints tab, the bone constraints tab. We are in pose mode, by the way, and this is the bone constraints tab. And let's go ahead and add the inverse kinematics constraint that we have been looking at this whole time. This is going to be the star of the show. So we're going to go ahead and add it to the shin or the forearm of the chain. So this will be almost at the end of the chain, but not quite. So the second to last bone in the chain will be the one with the constraint in it. Now the reason for this is so that it can have a target that's a little bit further down the chain that will drive the rest of the chain behind it. So that's why it's the second to last, so that the last one can actually be the driver of the chain's movement. So here we have the IK on the second to last bone in the chain, which in this case is the forearm. If it's the leg, it'll be the shin. So I'm going to go ahead and add a target here, and the target, of course, as you guys know, will be the hand. And so I'm going to go ahead and select the armature here, which is meta rig, and then add hand. I'll do .r for this one, and this .r will be this particular hand. Now let's go ahead and see if this works. Hypothetically, we got a few other parameters in here, but I'll talk about them later. So let's go ahead and try it now. But before we do, I'm going to go ahead and turn off Auto IK so that we don't get confused as to which system is actually working. So I'm going to go ahead and select this hand now, and I'm going to try to drag it. Let's see what happens. And nothing happens. So that's pretty anticlimactic. The reason for that is actually for a very good reason. It prevents a very specific problem which is called a loop in the parents. So if you guys just think about it for a second, right now what we have this bone, the forearm bone, being constrained to follow the hand bone, which is actually the child of that forearm. So what's going on is the forearm relies on the hand to know where to go, but the hand, being the child of that forearm, relies on the forearm to know where to go. So what ends up happening is they rely on each other to determine their location, and therefore when one moves, the other one moves, moving the other one, moving the other one, moving the other one, which creates a positive feedback loop, which would then explode everything and kind of be unpredictable and would just keep going, kind of like an infinite loop, right? So we don't want that. That's called short circuiting in my book. I call it short circuiting, kind of like how an electrical circuit short circuits that way as well. But what we're going to do, and what people usually do in this case, is they create a duplicate, because while as much as we want to disconnect the hand entirely, it's still going to be deforming this hand. So we don't want to stretch the hand off the body itself, because then it'll actually be visible. What we want is a duplicate invisible bone that sort of doesn't deform anything but acts as a controller. So what we're going to do is I'm just going to go ahead and duplicate this hand with Shift D and then right click, and that will give me a duplicate hand bone. As you can see here, hand.r.001, which means it's the second one, and that will be in the exact same spot with the right click. I'm going to go ahead and rename this into hand_ik.r, and that will be a little bit more descriptive for us. As you can see here, we still have a relationship line with that forearm, which we don't want. You can also go here and just see if in the bone settings, in the bone properties, there is a parent parameter, and we can just actually just X that out. And so now it's no longer parented to anything, no relationship lines, no dependencies. So just to double check, this guy is connected indeed, so that's great. And that's exactly what we want for now. So once we have that, I'm going to go ahead and select this constrained forearm again, go to the IK settings, and change this target to, instead of hand.r, to hand.ik.r, which is our new bone. So this new bone is not parented at all to the forearm, which means there's no more loop in the parents, which means it should allow us to actually deform the forearm based on the hand's movements. So let's go ahead and try it. I'm going to go ahead and drag this over, and it looks like, yes, something's happening. So this is not exploding. This is not loop in the parents at all, but there is something very weird going on here. A little fluid, a little funky. He's a very happy-go-lucky snowman, and it looks like he is being dragged by this hand. It's like almost like I'm dragging him up with my mouse or something like that. Now, of course, that's not what we want. What we want is just for the arm to be dragged, not the entire body. So the reason why this is happening is because of a setting in the inverse kinematics for the chain length. So this, when it's set at 0, automatically takes the entire chain, which, by the way, goes all the way down to the hip. And we don't want that. We want it to only last up until the beginning of the arm. That's where we want the IK to stop. So we're going to go ahead and change 0, which is infinity, to a finite number, which is going to be 1 or 2. And the reason why I say 1 or 2 is because 2 is going to be what we want to use. And you can actually count that just simply by counting the bone that is constrained and then all the bones that come after it. So 1, 2 is 2 bones in the chain that we want to actually bend based on the hand's movement. So the forearm and the upper arm. If you ever need more, you can simply up this number to however you need. As you can see, that yellow line goes to the base of the final bone in the chain that you want. So we're going to do 2, a chain length of 2 there. And as you can see here, when I move, go ahead and make sure you select the hand ik.r. It's a little bit hard to see because they're overlapped, but you can actually double check to see what you have selected. And if you can't select the right one, you can simply keep your mouse in the same position and keep right clicking until you get the right one. Now, once you have that selected, the IK one selected, make sure you have that one selected and try to move it. It looks like we have a pretty decent IK hand here. So I want to bring this into solid mode just to get a little bit more perspective. And as you can see here, we have a really nice bendable elbow. And once this controller goes past the point of full extension, it just goes off on its own, and that's fine. That's exactly what we want. And that's how most IK controllers work. So that works pretty good. And yeah, it's a very intuitive control. So that's a good start. But there's a couple problems with it. Luckily, there is a very distinct bend in the bones here to make that elbow very obvious as to where we want it to be. But that's not always the case. For example, if we ever wanted to bend it, say, upwards, right, and we wanted the elbow to be below the basically be below the hand instead of behind the hand, right? Here we have, let me go ahead and turn off the x-ray since it's a little bit hard to see. So this elbow here is still pointing backwards. We could be trying to get Archibald to be reaching upwards, which means that the elbow usually for a reaching upwards motion is going to be below the hand, like right below it. But I mean, we could try to, we could go here and we can rotate the bones inside of the IK. It's not very pretty. It's not very, neat or easy to handle at all. That's not great. So there's another parameter in the inverse kinematics options called the pole target. Now the pole target is basically a object or bone that the elbow or knee will point to. I like to call it the knee target or the elbow target as well, just to make it a little bit more easier to understand. You basically just have the elbow point to that object so that you know it will bend in that direction. So you're going to point it right there. So making a sound effect for no reason, because my elbows don't make noise. So we're going to go ahead and create an elbow bone here. I'm going to go ahead and copy. I'm just going to go and duplicate the IK bone just for, to make it easier on me, and then put that right around there. So this is a good spot for it, I think. We're just going to leave that there. I'm going to name this elbow.r because it is the right side along with all the other bones here. And let's just leave it at that. Let's just leave it at that for now. I'm going to go ahead and zero this out real quick. Make sure, sorry, I'm selecting the wrong bone here. Make sure the correct bone is selected. There we go. That's the IK bone. And that will, let's go ahead and turn on the X-ray again real quick. And that will allow me to select the elbow as the pole target. So I'm going to go ahead and select meta rig and then elbow.r. Now you'll notice this is not exactly desirable. He looks more like a chicken now for some reason. But the elbow is pointing in completely the wrong direction. Dillon, I thought you said the elbow would point at the target. Well, that's only if you tell it to. It will use the target as reference, but it doesn't know exactly which way the elbow is pointing at all times. You have to tell it exactly which way is the correct way before it starts following. As you can see here, it's sort of following with an offset. So what we're going to do is we're going to make sure that this pole angle here, which is used specifically for the purpose of adjusting this rotation, to make sure that the elbow actually does point exactly where we want it to. So let's move it back and forth a bit. It looks like we have to go negative, and that's fine. So just find a negative value that works. And it looks like a value of approximately -90. I'm just going to try to do a relatively round number, as I like to make round numbers so I can copy it over to the other side as well. But that is a pretty good number, and it looks like now with that, make sure you select the right bone, we actually have a pretty decent pole target. So we can actually get this thing over here moving above him, and then have this elbow sort of follow his there we go, his hand if we wanted to. So one other thing that people like to do, depending on your the rigger, you can also instead of having to move this manually each time, this could be more intuitive or less intuitive depending on what your personal preference is. But I like to personally parent the elbow to the IK. So I'm just going to go ahead and go in here instead because I can't really easily select it. I'm going to set the parent to the IK.R bone. And what that'll do is allow me to just select this IK bone, bring that here, and then if I want to rotate the elbow, just rotate the IK bone. So I don't even have to select a different bone to animate that elbow. You just simply drag and rotate. Drag and rotate. So that will be very intuitive for some people as well. So that's the basics of inverse kinematics. There's a few other things. For example, if we go back into this constraints menu, like position is by default on because that's the most important. You can turn on rotation, but you don't really have to. I've never really seen a use for it, to be honest. There's also the influence, of course, which can be keyframed, or it can be driven by some sort of driver that will allow you to turn off and on the IK, which is actually very helpful for switching between IK and FK. Because once we turn this off, you can simply control it normally, and then you can turn this on, and then you won't be able to. It'll be an IK control. So you can switch between IK and FK, and you can keyframe this simply by right-clicking and hitting Insert Keyframe, and it should turn yellow, or you can just hover over it and hit the I key. Now there's one more thing we need to do for the IK, which is if you notice, if we actually grab this hand here, the IK bone here, we have the elbow back in the back. It'll look kind of strange with the X-ray turned on, but the actual hand bone itself is a separate bone entirely that you have to sort of manually rotate. This doesn't actually rotate the hand, it only rotates the elbow back there, but that's not ideal. In fact, normally, let me go ahead and undo this parenting by clearing it with Alt-P, just so we can get a good idea how this rotates here. This IK bone, its rotation is basically wasted, and this guy is going to rotate sort of in the most intuitive way, but that's not actually the way that we want it to, and will require us to have an extra click just to rotate the hand. So just a simple advice, I would just add a copy rotation, add it to the meta rig, and have it copy the rotation of the of the IK bone. So just turning that on will save you tons of time. So let's just go ahead and do that. And as you can see here, now you can just rotate this. I'm actually have the IK bone selected, as you can see. Now you can just rotate the IK bone and it'll rotate the actual hand. And it'll also maintain the rotation of the hand as you grab it and move it around, as opposed to pointing it in the same direction as the forearm. So that is a very handy tip that I would that I would recommend. So that's it for IKs in Blender. I hope you guys learned something.